these problems we are asked, write the expression in terms of sine and cosines only, and then express your answer as a single fraction. Iser, how do you write cotangent of x using sines and cosines? Which identity is that? Quotient identity. Jocelyn? Which identity? Quotient identity is correct. Class, can I subtract the two fractions? No, we need a lowest common denominator. My common denominator is sine times cosine. What does that mean? This sine has a sine in the denominator. This one does not. In order to do that, I would have to multiply by sine over sine. I can multiply any number times 1. This time I'm going to multiply by cosine over cosine. Eileen, C, cosine times cosine. And we multiply those two, it's the same. Eileen, sine times sine. And the denominator? Cosine, sine. Now, I'm thinking to myself that I see sine and cosine squared. So I'm thinking of the Pythagorean identity, but let's see if we have to use it or not. David, what is the Pythagorean identity that has cosine squared and sine squared?
Sine squared theta plus cosine squared theta equals 1.
These are abbreviations. Don't use abbreviations on your quizzes or tests. So can I get it where it says cosine squared minus sine squared? Can I do that?
Well,
I could try a couple of crazy things. Maybe just change the order. If I multiply by -1, would that do that? This would become a negative and negative. That would not become subtraction. So the best thing, I cannot use the Pythagorean identity, even though it has both a cosine side. I tried it, right, to see maybe some variations. And so I just have cosine squared x. Now it says one fraction, so I'm going to write minus sine squared x over cosine x sine x. And that's our answer. Let's try the second problem. Nicole, what did you do first on this one? Okay, so we're going to change all these into sine and cosine. So that's our kind of hint.
Secant turns into 1 over cosine.
1 over cosine is correct. And how about secant?
1 over cosine.
1 over cosine. And which identity did you use? Shiv? How can we simplify this now? Okay, we can cross multiply if you see an equal sign here. So here you're just going to multiply across. Go ahead. Now there's a couple of things you can try here. You could do something like tangent, using the quotient identity, tangent x minus 1. That would be acceptable. But I wouldn't accept that because they want it as one fraction. They want it to be kind of together. So class, do we have a common denominator? So what can I write in the numerator? And the denominator? Just cosine. Remember, you're not doing anything like canceling or anything like that. And that's our answer. So change everything in sine and cosines and then make it one single fraction. Class, what do those turn into?
1 over
Sine of x and 1 over sine
x.
and this one turns into a
1 over cosine x.
and the green box, which identity basically were we doing here?
Reciprocal identity.
Reciprocal identity. Okay? So now I have a fraction within a fraction, and I'm just going to turn sideways. Sine of x divided by 1 over sine of x plus cosine. Why did I do that? 1 over cosine of x. Class, can we cancel these signs here? Even if I made it a fraction over 1. Could I cross cancel?
No.
Why not? Yeah, it's division. So we need to change these into what?
Multiplication.
And what happens to the second fraction? You take the reciprocal. So now I have sine of x times sine of x plus cosine of x times cosine of x. Sine times sine is?
X squared x.
And cosine times cosine is?
Cosine squared x.
Sine squared x plus cosine squared x is equal to?
1.
Which identity is that?
Pythagorean.
The Pythagorean identity. Raise your hand if you got that. So if you get stuck with the fractions, my fractions are vertical, and then I call it, you have to turn it horizontal. So it's like this, turning it sideways.